Hello guys, in this video I am going to explain about what things to know before going to analyze the package. Okay, what I'm saying is taking this tool as a game. What you guys is doing before starting a game, you need to set up a profile, right? Before jumping into the Wireshark analysis, we need to set up some things which could be understand easily, so we can easily capture them and we can easily analyze them, finding them, and all of these. Okay, before going to set up the Wireshark, I'm going to explain about these topics. Yeah, name resolution types and drawbacks of NR means a name resolution, protocol dissection, hierarchy of protocols, and TCP string. These are the things before going to analyze, we need to master it. Like, we need to know what's going on this here. Each topic has its own importance. So, when it comes to name resolution, you know that ARP, right? ARP. What is meant by ARP? Address resolution protocol, right? What is it doing? The main job of this ARP is converting the MAC address into IP address. So why? Why it needs to converting the MAC address into IP address? Because if you're having a Wi-Fi in your home, if you're having a Wi-Fi in your home, the Wi-Fi has a MAC address or LAN, that physical devices. This is a MAC address, and your computer has a MAC address. Both need to communicate to each other, right? So, if directly communicating from the internet, it could lead to some hacker join this network and possibly able to hack your direct machine, right? So, in this way, the ARP was converting the MAC address to IP address to protect you from the attackers. So if we use IP address, we can have the firewall for the particular network, and attacker might not be entered. So when you have the MAC address, the MAC address is a permanent, but the IP is can be changed, right? Yeah. So basically, ARP this protocol was used to change MAC address to IP address, MAC to IP, and uh, DNS. Yeah, DNS is also a resolution type because when you enter any domain, for example, google.com, if you type any in browser google.com, it will change that domain into IP address, which is um, related to the Google DNS, right? So if we want to access that Google address, we need to type google.com. So instead of remembering all the types of IP address, we need just having the domain names, which is called the DNS. What does DNS do? When we enter, when I enter any DNS name, for example, google.com, it will give that name to the DNS and it will check in the records, for example, A record or a triple A record, all of these records. And if that name was associated with the specific IP address, it will try to connect with the Google server. When the Google server is available, it will repeatedly give you the result. Yeah, this is how it works, the DNS. When it's come to drawbacks of name resolution, the main drawback of this name resolution is when you capture the any traffic. When you capture any traffic, when you when you want to analyze it, it will remove all the DNS queries in the background, because when the internet is automatically connected, the queries will be automatically um, surrounded by the queries, because the internet wants to connect to that particular server. So the query was being around the internet was very little bit to perform analysis on that captured file. So this is one of the drawback of the name resolution. I will show you practically so you can understand it. And the protocol dissection. What is this? So we have the different protocols. For example, HTTP and FTP. So all these protocols carrying the credentials of a user. For example, if I enter any credentials in a particular site, it was carried by the headers. We know that headers and data files, all those things. Header carries the information and also the data across the internet across the internet and received by the server. And the server replies if the credentials are legit, it will receive successful, and the credentials are not matched in the database, it will receive the error, right? So in the same way, the protocol dissection means we have to find which protocol is used to carry out that credentials from the user to the server. So this is all done in the application layer and the presentation layer, because the application layer has the user interface there, and whenever the user try to input some credentials and click on enter, it will go through the second layer, right? It was a presentation layer. So in this situation, we need to find which protocol has the data. This is the most important thing before directly analyzing the packets. And hierarchy of protocols, what is this? For example, if you have a organization constantly using the DNS server at 20%, so the DNS server using it the 20% of its current potential, right? So when it a particular certain time it uses 80%. So you might be encountered that this DNS server is overloaded because of some attack. This is the indicator of an attack to crash down the DNS server. Okay. What is the TCP stream? So in any analysis, the TCP streams plays very important role. For example, UDP, if you take UDP, we know that UDP is a User Datagram Protocol, right? The UDP sends without the aid of receiver was receiving or not, it would uh, continuously sending the data. But in UDP, before sending the data, it was a mechanism called three-way handshake, right? The three-way handshake, they both know if they're available, they will continue that uh, information transmission. So if the three-way handshake was failed, no data was transmitted. But in UDP, if the user is receiving or not, they don't care. It was continuously sending the data. But in TCP, we need to analyze what is three-way handshake, how does it done, and if the three-way handshake is success, how does the data flow in that stream? Okay, let's get into Wireshark. Let's take the DNS first. Now I'm currently started the new capturing data. If you take the application data was secured by the TLS, this is the version name, record layer, okay, HTTP, hypertext transfer protocol, and the context is application data. What type of application data? This is the data which is encrypted by the TLS, and the application protocol was transmitted with the help of hypertext transfer protocol. So let's see the DNS, or what is the TCP. Here, the protocol, the destination, source, time, and number of bits or number of the current flow. So what is the length? Okay. Now I need to see the protocols here. So when it comes to DNS, when I click on this DNS, what is this domain name system? It is a query. What I said earlier is if you capture any traffic, it was continuously sending that query to maintain that constant connection between you and the server. So we have the transaction IDs and queries, what query, and this is the IP address, and this is ARPA, and additional records is root type OT. Let's dig into deep name root, which is a rooted device out there because it was a server, right? And this is all about the queries. So how this query works here? Before connecting it to the main server, it was send a query to that server. And the query has the transaction ID and the flags. What is the information here is response. Message is a query. Standard query. Message is not truncated. Do not recursively. Non-authenticated data is unacceptable. This is the flag that every DNS query follow, because before going to this deeping to connect that server, this is the rules that it follows by the DNS server. So what are the rules? Message is query, response should be message is a query, and the opcode is standard query because it's zeros, whatever it is. The message is untruncated. Truncated means it should carry some it does not drop any bits during that query transmission, and that do query recursively. So it should desire the recursiveness, and reserved is zeros. Non-authenticated data unacceptable means when it want to connect to the main server has data transmission right. So that data is not unauthorized or non-authenticated. It should not be acceptable. This site is not safe. This type of error when we search anything on the internet, sometimes we encountered with this page is not loading, or this page is not safe, especially not safe because it has non-authentication data, right? When the non-authentication data is there, it is not unacceptable. That's it. Question is one, answer should be zero. And these are some queries. What queries? This is a name length should be 26. So if the query, the DNS query is satisfy all this information, then it was ready to send the data or receive the data. Yeah, this is about the DNS, and next topic is hierarchy of protocols. Let's see what is the hierarchy of protocol. In the statistics, I think no. Yeah, I think it's a statistics, right? Yeah, in the statistics, there is a protocol hierarchy feature. So, in what I am capturing when I click on protocol hierarchy, so these are the information I got. Let's see that DNS server is using the percentage package 1.9, and the packet is 40, and the percent bytes is 0.5. So when you encountered with any specific type of numbers that look like suspicious, resolve that. So if you want to dig deeper, you can go through every detail and what is the normal percentage of the DNS in the protocol hierarchy statistics in Wireshark. So when you question that in the internet or when you ask the chat GPT, you can get the answer. So these are some things here. And when come back here, Let's see about TCP. What is this TCP was saying is, when I click down here, the source port and the destination port and yeah, conversation. So when you see the conversation here, what is the color of this failed incomplete TCP stream is red color, because it was not completed that three-way handshake thing. That's why it was indicating that. So let's see how the three-way handshake working in this internet directly. Okay, first thing is reset is absent, because the another server or whatever that is the receiving server is not accepting that our packets. So when it accept, it was finished, but the finish is here the absent, and the data is present in that layer. The acknowledgement is present, but the sync and acknowledgement is absent. We know that first the client server, the client sended the sync, and the server is responding by the sync and acknowledgement, and then our client and server is ready to communicate, right? But that sync and acknowledgement is absent here, and the sync is also absent. That's why the conversation was incomplete. Yeah, this is how it done, and this is how it represent in that message was sent to that server, zeros and ones. So the zero is means fail, one means pass, zero means absent, one means present. We cannot find that the red color TCP under the normal TCP. Here the rest means zero, absent, and the finish is present, data is present, acknowledgement is present, and synchronize and acknowledgement is also present. Sync is also present, because there is a successful three-way handshake between the client and server. Before going to analyzing the packets directly, this is what we learn. Understanding how the system works, how the TCP clients works, and what's the messages behind that, how the two computers will be coordinating and communicating. You can find there is a different type of colors here. How I configure this. In the next video, I'm going to discuss about this. Thank you. If you find this video helpful, please subscribe to my channel. Bye bye.